Hello everyone, welcome to a new section on the relational algebra. In this section, we will introduce a bunch of operators we can use to do the queries on relations we defined before. This section will serve as a foundation, theoretical foundation for us to use SQL to be chosen later. In this section, we will not touch SQL at all, and however, we will provide a theoretical design of query language we can implement to do queries based on relations or tables. So this section is more close correlated with theoretical design of the database systems as well. And I'd like to provide you with some high-level ideas about relations among different sections. And in this page, I show you a diagram about some sections we cover in the course. At the very top, we have the real world, right? Because we know in the real world or applications, we can have very diverse and also very complex information. However, if we want to create some websites, we want to store the real world information into our database systems, then we have to do the modeling, right? The modeling of the real world. Because the real world is very complex, when we do the modeling, we hope the language we use can be very easy and very simple, right? We don't hope to write code directly when we do the modeling. Therefore, we propose a ER model, a very simple model, which can be used to model the real world application of this diverse and complex information, right? In the ER model, we represent all this information into a bunch of very simple diagrams or basic structures, right? We have these rectangles, we have diamond, oval, as well as triangles and etc., right? So in the ER model, the structure is very simple, very easy to draw on your paper, right? And after we do the modeling with the ER model, we can get the ER diagram, which is some plots we can draw on figures, right? So this step is necessary to model the real world, diverse and complex information. It is a ER model we covered in the previous section, right? However, the ER model is far away from machines or from computers. We cannot store everything into diagrams in our computer, right? It will be very hard. Therefore, we need to have another model which can translate everything in the ER diagram into some relations or some tables. Then we introduce the relational model. It is another powerful model we can use to do the translation of the real-world complex ER diagrams into one single type of concept. It's called a relation, right? And after these two models, then everything we have in the real world will be represented as a very simple concept. It's called a relation, right? Everything will be into a relation after we do the modeling. These two sections focus on the modeling, right? And after we get the relation, then we need to do some queries. This is very important because in the real world, we have to do some operators on the data, right? And which may require some queries for us to help us. And everything in the following sections will be based on the relations, and we will ignore the real world, we ignore the ER diagram or the relational model. Everything will be based on relation. Relation will be the key concept in the following sections in this course. So everything we have will be in relations, right, or in tables. And we need to do some queries on the relation, right? Then we can go to the left branch, we do the queries. Query, we need to have some language, and many of you may consider the SQL language can be used, right? However, before the SQL was implemented, we need to design what kinds of language we can use to do queries, operators on the relations. Therefore, before the SQL, we need to have a theoretical design of the SQL first, which is called the relational algebra. In this part, we provide some theoretical design of the language we need to have, or some basic functions we need to have in the language we can use to operate on the relations for queries, right? So this section is focused on the theoretical design of the query language. What kind of operator we need to have and how to use them to do the queries in a theoretical perspective based on the relations. This is the focus of this section on the relational algebra. This section will serve as a foundation, a theoretical foundation for the SQL to be introduced later. because everything we cover in this section will be implemented in SQL to help us to do queries for us in the real-world database systems. And based on this one, we can go to the application language we can use in programming. It is called SQL. So this application is relatively easy to learn compared with the theoretical design of the query language, which is very hard. I also mark a red star here denotes this is a very hard and challenging section. On the relational algebra, we need to design the theoretical language we can use for the queries. This SQL will be covered after the midterm, and we will cover this section very fast because it is just an application language. You can just use what we cover in the lectures on your programming. It is relatively easy after we cover the theoretical design on the relational algebra. This is the left branch on the queries. Let's go to the right-hand side. Based on the relations, we have another section. It's called Relational Design. In this section, what we want to do is actually to polish the relation we can get from the translation. Because after we do the translation, the relation we get cannot be perfect. They may still have some problems, right? They may still have some problems. And we want to further polish these relations into better ones. Therefore, we have one section on the relational design. And via this section, we have a bunch of techniques to be introduced, which can help us to get some polished relations. In this polishing process, we need to ensure the new relations after this polishing process, they need to follow some theoretical normal forms. You may have heard some normal form like pseudo normal form or BC normal form, right? This is a very difficult concept. And we need to ensure these new relations can follow the normal forms and has certain properties, which will guarantee the relation we can get can achieve certain performance, right? So therefore, you can see these two sections to be covered before the midterm. In the remaining classes, they are very difficult. They are all about a theoretical perspective on either the relational algebra or the relational design to get polished relations. They are all very difficult. So I hope you are prepared for these two new sections. And I also hope this diagram can provide you with a big picture about the organization of the sections in this course. From the real world, we do the modeling first with the model. This is easy. We draw diagrams. And then we have the relational model. We translate the diagrams into relations or tables. The relation we have can be not perfect, then we have to further polish. We have to further polish them into better relations, which can follow some theoretical normal forms. And based on the relation, we can further to do some queries. We need to have some query language. It will provide both a theoretical design of the query language, which is the relational algebra, and also provide some information about application language we can use, which is called SQL. So this will all be covered in this course, and I hope you can know why we have these sections and why we move from the real world step by step to the remaining sections in this way. And I also need to remind you about these two sections. They are very difficult. So be prepared when you are studying these two sections. You need to spend lots of time on these two sections, on both go over the materials in the textbook, the slides, and the lecture. And you also need to spend lots of time to find some questions or in your homework or some other questions in textbooks to work on them by yourself to guarantee you can follow what we cover in these two theoretical lectures very well. In this way, you will be able to learn the database system very well. Okay, this is the outline of this section to be covered. In this week, we will go over the relational algebra first, and in the following weeks, we will work on the relational design to polish the relations. Okay, let's come back to the slides.